So yeah, today's topic is classes. It's a very short chapter, but yeah, it's a little bit interesting. So the first primary concept that it talks about is about the small classes. So I just added a little bit of spin onto it.
Mhm.
Um, eh, yeah, so just started. Yeah, so yes, I just we just added a little bit spin on it because it's the point of discuss was it's a little bit. Yeah, I mean I don't agree with writing very small classes. So that's one of the things. Yeah,
Oh,
then we just
interesting.
yeah
Okay.
go into revisit some of the finger responsibility principle. Yeah, and then it just talks more main of cohesion is mainly from a class structure, like how do you want to uh, manage a class. Again, comes a little bit into this uh, periphery. Last one is an open or class closed classes. This will talk in terms of what are the there's a principle or open or closed principle, open closed principle, a part of the solid principles. The second one. So basically, we're covering two principles in the solid framework. One is a single responsibility principle, and the second one is open closed principle. So yeah, so we'll talk a little bit about that. Yeah, so that's what we're going to call. Quickly jump in. Yeah. So when we talk about small classes, like I think in the book he does mention that the classes should be small, as small as possible. But that has its own problem that you will have a scenario where you will have many small classes, and then yeah, at one point of time you will just see think about it. What's the point of having so many classes? Yeah, you can just merge them into one particular class, and that's where the concept of deep class come into it. It's a I think concept. Um, the one person who I know works about is John Osterhout. He talks about having classes deep. So you have one particular concept, and that concept you put everything into that class, so that you really know that why that class exists for and what the values of that class are. So I think I'll just share my screen code. Uh, you able to see my screen? Uh,
Yeah, it is.
Yes, yes.
the code, right? It does show you the code. Uh, yeah. So the so one of the examples that he has given in the book is about this sequel. Now, this is a very good example in terms of this is the final abstracted version of it, like the refactored version of it. In this, if you look at it, the classes are small, and each class has got one method to work with it. So they just have got one method. So you have one base class, and then everything is extending from that particular class. So this is a actually a very good example of how to write classes, which is like small enough. But this can only work in for this kind of very well defined scenario. So not a lot of the times it's hard to get into this. Can you can get a very such clear abstraction. So that's one of the reason why it's hard to have smaller classes. But on the flip side, you also don't want very big classes. So like this is one of those ones. Like you have thing called login operations, and there are a lot of methods down here. You have retrieve login response. S- so whenever we are looking into this detail, we kind of focus on the public methods. So there are a lot of public. Just focus on getting the public methods out because those are the ones that are the interface to that particular class. So you have a retrieve login response. Then you have retrieve user sessions. So we are talking about login response now. It's about session, and then there's a user session map. Yeah. So I think those are the three primary method. But if you look at it, you can clearly say that this one is talking about user session map, and then you have user session, and then it talks about login response. So it's basically doing two or three things from this particular, just looking at the class, not even looking at the logic, etc. So this is a very strong candidate where we can kind of split it into classes. Like we can kind of say we have a class specifically for user session, and specifically we could have which would have those two public methods, and the one related to the login response, we can have it a different class. So that's one way of looking at it. So this becomes one example where you can kind of know that you know what this is the class is too big and it kind of has to split into it. Any thoughts?
Uh, Sorry, I'm just thinking about the whole deep class part.
Yeah,
Uh, yeah, so are we saying it's more like a cluster of classes? More, are we saying that at its basic, like a cohesive cluster of classes? Is that what
yeah,
deep?
it's yeah. So yeah, I will give an example. This is another example. So if you look at this one, you have FTL contract operations. It has got again a lot of things, but essentially in this particular class, we only have got two methods. So it's pretty
Mhm.
big class. Like you have around 500, yeah, 700 lines of code there. But
Mhm.
primarily what it is doing is there's one assign FTL contract to a customer and then approve FTL contract. That's it.
Mhm.
It's not doing anything else. It says FTL contract operation and then it just talks about two specific interfaces it's doing to it.
Mhm.
So
Mhm.
now having one public class for both the methods, it would have become overkill on that front because
Mhm.
we are splitting that concept of FTL contract in different things. And similarly, if there are more functions or more features that comes in terms of FTL contract, maybe a reapprove or whatever, then
Mhm.
you can kind of go ahead and add this into the class without uh, causing any other problems.
Mhm.
So
Mhm.
that's one part of it, and then
Mhm.
uh, there are things that if there's some very complex uh, logic, right, where
Mhm.
you have different. This comes out from a testing perspective. So suppose if you have, you need to calculate the contract value based on certain rules and everything else, and the thing is that you are trying to test that rules.
Mhm.
So if you have it in the or say the whole operation, right? You want to calculate the total contract price, and it has got some 10 different rules. It needs to or even three rules. It needs to look up, and it needs to take up some values and calculate a final contract value. So now that scenario, because that is a if I put this that scenario saying that public calculate, it will not be a public one. It will be like between your private method and then you say calculate contract price. So there's some this method is there, and then say the assign FTL contract to customer, it might call this particular method. Now when and it will have some complex logic to do it. And then when you're writing tests, what would happen is you need to assign FTL contract to customer, but then you want to check all the rules, whether those rules are getting implemented correctly or not. So what you in that scenario, when you try to write tests, you actually are looking to test this method, but because this method is private, you cannot directly test it. So what you would do is you would test this method, and then whatever the other things, we'll just mock it up, and we just play around with different values to ensure that we are getting the correct whether this complex logic is executing correctly. So in when this kind of thing happens, when you are mocking this particular public method, just to test this particular calculation, that is like a prime candidate to move it into a different class. And then because when you move into different class, whatever this calculation, you can kind of you're going to write a unit test for that particular class, and then you can really calculate, do all kinds of testing only on this particular method, and you don't need to test this one. That's how you kind of separate it out, saying, yeah, this calculation is complex and I need a lot of variables to it, so I just pull it out into a separate class just for a calculation piece. So that particular class might handle other calculations. It might handle some other. This was from a contract perspective, but there might be other calculation that you can add into that particular class. So then that becomes a different entity. So that's how you kind of split, and or otherwise you want to keep it in the same way. That's how you kind of decide how to keep it in the same logic, whether it should be within the same class or whether it should go to a different class. Did it make sense?
Yeah, I see where you're coming from. Yeah, yeah.
So, and one of the things with this SQL dot so this one, this is this primarily implementing uh, this inheritance pattern that we have, and
Mm,
it's a very good. This is one way of doing it, where we can have smaller classes, and then there's one more thing I think for strategy pattern. We can use this kind of a approach where you have um, different if else condition, like if this if the value is x, do this. If the value of y, you do this. So there are like switch cases in your code, like switch, approve, switch, assign, and so on. So a lot of different cases are there. In those scenarios, you can kind of convert the switch cases into strategy pattern where you create smaller classes. That also works pretty good for that particular from a pattern perspective. And then the code becomes much cleaner. There will not be any if else. There won't be any switch, and it will come out pretty cool. Yeah. Uh, so that's a deep dive into this one. I'll just move ahead. Yeah. Yeah, the other thing is, yeah, follow single responsibility principle. So yeah, whenever you are doing this, for example, this one, FTL contract, it is only talking about FTL contracts that the single responsibility principle is following. And as I said, all the calculation, you put a different class, that would be a different, responsibility. If that particular class, the responsibility would be only calculation of the price, but this one would talk about only FTL contract. And if you look at this login operation, this is where it's kind of mixed up, where you have a lot of different things that are there. If you look at this method, I think I missed this. You have admin login response is there. Uh, yeah, then you have retrieve cookie list, and then you have user session and retrieve user session map. Yeah, so it's you can kind of have I think 3 or 4 classes out of it. Like one class only to validate the login, whether the customer gave proper or correct the client, the user has given correct login. Then there are 2 types of users basically. There's an admin user um, and then there would be a normal customer user, um, and then the other possible class would be a user session class to manage all the sessions, and then the another class would be like retrieve cookies. That so it might be related to a cookie class, like how do you want to manage your cookie and so on. And if all of them have got a validation of login, then you kind of call them. But yeah, so again you can see this is user vendor type, user type, and is user customer. So yeah, this class, you can kind of do a lot of this will split into like maybe 6 or 7 classes based on how you refactor it. So yeah, and it's clearly one of the anti patterns of that. Yeah, so the main problem that we generally see in the code is like either there are too many classes with very small things, or there will be one big class. I think he calls it God class, like having everything inside that particular class. So yeah, this login operation is something like that. It's just like God class. It got like a lot of things inside there. But you can see the number of lines is only like 260. So it's not from a length perspective, the class is not that big. But when you look at the number of things that it is handling very different things apart from login. So no, it's breaking that single responsibility principle from that perspective. Um, all right. Any thoughts?
Yeah, I was just wondering. So on one hand, it's God class, obviously, which we shouldn't be doing. The other
Yeah.
end, a lot of small classes will also have this class explosion, right? I think that's the term that's used. Yeah, class explosion.
Yeah. Yeah. Class
Um,
IDs. You mentioned class
class
IDs.
ITs, huh? Okay, interesting. Um, yeah, so you're saying that so that we don't tend to either end of the spectrum of this, we
Yeah.
should have this deep class. That's a good way of setting it up, organizing it.
Yeah. Organizing the
Then
code.
okay.
And then when you write those test cases, as I said, when you write those unit tests, it kind of tells you where you are doing a lot of mocking. Whenever there is a lot of
Mm-hmm.
mocking happening, just to test a particular set of code, which it means that it's a candidate to be pulled out of that particular class.
Mm-hmm.
So that kind of
Okay.
One question,
yeah,
not related to classes but to methods. Like,
yeah,
if I have a very long, lengthy calculation, but the return value is supposed to be only one, and that is being used only at one place, but there are no dependents also. But the calculation that ensues is very long, and then you have ticks errors, like complexity increases. There, we should use modular code, or we should leave it inside that, because then the length also increases and you have to hop at one place to another spaghetti codes.
yeah. I think it's always good if it's a complex one. It's always good to put it in a different class, and that the method will be living by itself in another class. Because yeah, the you then you can write a lot of tests around it, and then those tests becomes your documentation for that particular logic. So if in future that logic has to change, your main class will not be. You don't need to change any of the things in the main class. It all that change will be in that separate class, and it becomes much more easier to maintain than in that scenario.
Understood.
Yeah. So going forward, yeah. Again, you just touched upon this one during this that we're going through the code. Like it's simple to understand but harder to implement. So you need to kind of question yourself every time as to uh, whether you're breaking it or not, or do you have more of multiple concepts within the same piece of code. The other aspect is like the public methods are the interface for the class. So all the other classes will say uh, for this login operation, the all the other neighboring classes they will know only the public methods of that particular class. So you just need to ensure that the public methods will tell you. It should be very clear as to what the public method will should align with the the object, the main responsibility of that particular class. If that there's a misalignment, like you can see here, having user sessions and login, response, etc., then obviously you will know that the class is not clean. There are some problems with it. So basically, from a public method is what tells you whether there's a issue in terms of the class organization. So go to the next point, cohesion. So yeah, I think this is also a good metric, but it's not really a reliable metric. So what it says is that you need to have a very small number of fields, basically the idea is that whatever the public methods you have should use all the fields of a given class. So uh, if you look at it, you have around cache API sessions, and so these are your fields that are present for that particular class. So idea is that this all these five fields should be used by all the methods that are there. And if you're not using, or if they're sparsely being used, like for one of the methods only one of the things are being used, you might think of breaking that up into a different class. So that this kind of gives, looking using this cohesion metric, you can kind of assess whether you need to break up the class into multiple classes or not. So that's a question. That's a thing that you can kind of decide. That will help you decide whether you want to put this into a separate operation or not. So that's and then yeah, the other logic is like if you whenever you have a big method, so this method it looks small, but for example, you have a user vendor and then user customer. So this method is small, but if you look at from a different perspective, like tomorrow there's another type of user that comes in, then I need to add another if condition. So what would I would do is like I will use this kind of a pattern where I will have a vendor class and then I will have customer class, and then within that there will be a method to retrieve cookie list, and then it will from the this particular class it will be just say retrieve cookie list and pass the class name, like whether it's a vendor or not, and then it will go and call different classes. So that's basically using the strategy pattern to do that for you. So this class, this one will become very small. It will be converted into many small classes, but then it will much be easier to read. So if whenever in future there's a uh, new user type, what we are going to do is we are just going to add a new class for it, and this particular thing it will just do it by yourself. So it's like one of the, let me see if I can get that example. Uh, so this one of the this is one of the refactoring exercise that I was doing. So you had a car operation class, and then it had this particular method, public void update car. If light is green, do this. Else, if it is yellow, red, this is like I just pulled out, I think one of the YouTube talks, and then implemented the code. And then if light is yellow, red, put in gear or a car stop. It's similar to the one we have here. If user type is user vendor user type, then do this. If user is customer, then do this. The same logic that comes into the picture. But then what I did is I did I think 2 or 3 rounds of refactoring, and then at the end of it, what I did is I just change it into light dot update car, and you have all these light classes. So this is your drive, stop, and put in gear. There's a just deals with the car, and then I had class interface called light, and it had one method saying update car, and then if it's a green, it's the update car will just do a drive car, a red would stop, and yellow would, I think, yeah. So it just checks whether there's a previous was red, then it puts in gear. Otherwise, it stops. So yeah, so you add the logic within these methods, and you see the classes are pretty small, like this is very small classes. And what that did is that the final car operation. So it was this kind of a scenario where you had so many lines of code. It just gets translated into light.update car, and all the complexity of the internal logic, they got abstracted into smaller classes. So this is like one of the ways of reducing your complexity of the code, especially for in this kind of scenario. If of this particular type, do this. If of this type, do this. So that's um, another way. And then a similar thing I kind of implemented using, so there was another thing called address selection. So you had different types of addresses. So we had some kind of logic like this, that if it is of certain address type, you return service address or shipping address. If it is billing address, then return billing address, so on and so forth. So you had some kind of logic there, and you kind of abstract it out using a strategy session strategy. There are two ways I did it. I can do it using strategy, and then the other one is like type conversion. So yeah, but yeah, if it's mainly in those scenarios where you have ease user vendor type kind of a scenario, where you can kind of do those kind of refactoring. Uh, yep. So that's where we split larger function to find opportunity to split into classes. So you have a large function with multiple if conditions, then you can kind of think of different patterns that you can use to split different classes. And the last one I already talked about, you write unit tests, and if there are a lot of mocking happening for some reason to test a certain piece of the entire method, in that scenario, you will know that okay, you can split into a different class. Yeah. Any questions? Okay.
No.
Yeah.
No.
So the last bit is on open or closed classes. So now before going there, right, we have this principle from Solid. The first one, S stands for single responsibility principle, and O stands for
Responsibility.
yeah open closed principle. So we
Open
already
close.
touched on single responsibility principle. Now we are getting into this open closed principle. So when you build your classes, you want to make them open for extension but closed for modification. So what that means is what we did it in this particular piece of code. You
SQL.
had yeah, the SQL Java, which has got uh, so many methods. They're all abstract, but you can kind of, if there is something, a new type of method that comes in, we kind of have to add another method into this, which means you are modifying this particular class. But when you do it in this fashion, like uh, it's a different way of thinking, basically. That you made it generic. You kind of find so you had find by key, select all, select, and then you pass column and pattern, and then you select criteria. There are 4 or 5 selects, different types of select. So what in the refactored scenario, what we did is we just created one select sequence, and then we Yeah, I think they added different. They added different classes. So for each different type of SQL, they added different public methods or different classes for it, and then you can pass it along. So tomorrow, if there's another different select type that needs to be added, we just add another class, and then that would extend SQL, and it will just implement one method that is generate the SQL for you. So that's a better way to do it. Yeah, it's much easier to remove check for complexity, and if a certain thing can be removed, we can just delete the class for it if it's not required. But when you have it in this fashion, you need to then find out where all it's being used, and it becomes more complicated. And the more the number of methods increases, you this becomes more and more complicated. Any thoughts?
Yeah, I was just thinking, even the context of the deep classes example that you showed,
Yeah,
how would this one pan out? Open for extension, closed for modification. And it's a
yeah.
similar.
So yeah, so in this scenario, yeah, in this scenario for deep classes, that will you are going to violate that particular principle basically. The one
Mhm.
hour modification, because whenever there's a new method or new method to be exposed, it has to be added in this scenario. So
Mhm.
this is the thing I think we talked about. I think few chapters before where um, we had two different approaches. Like one is the procedural approach and one is object oriented approach.
Mhm.
And you decide based upon uh, yeah, how your code organization would look like. You kind of decide which approach to take. So if you take a object oriented approach, it creates a lot of classes, but it is yeah, yeah, let me go through that. Yeah, but it creates a lot of more classes if you create an object oriented thing, but then
Okay.
it's easier to maintain. But if it is procedural, then it's very easy to add more functionality, but it becomes grows very complex very quickly.
Mhm.
So again a design decision that you need to take as to where you are heading a particular class. Uh,
Okay.
yeah.
Shit,
So
how
yeah,
about we make this class abstract and then add the new modification into the extending class? Would that be a good idea or a bad anti-pattern?
yeah, that's a good question. So one thing that uh, see earlier when we had right when you had this interface approach, there would be a lot of interface created, and then there would be a lot of implementation classes. And what would happen is that you have a interface called FTL contract operation, and then there would be a class called FTL contract operation implement IMPL, like they would just do like that. And what it's like basically in the EJB word. And then what would happen is that whenever somebody has to create a new class, what they would do is just go and create an interface, and then they would create an implementer class kind of thing. So, and then it just multiplied the problem. Like you had so many interfaces, but it doesn't, that interface doesn't do anything because it's sitting in the same package. So, so now if I have a scenario where, so for example, I started with FTL contract operation, and then later down the line, I have maybe a different type of contract, right? So then maybe I can create a class called, public sorry, interface, interface, this one, contract operation, and then you implement. So this class will implement uh, contract operation, something like that. So then what would that do is, like, for each different type of contract, you can implement a contract operation, and within this, the primary methods will remain the same, like assigning contract, approving contract. Those will be in the interface, instead of the public method and assign contract, and then approve contract. So then when you're implementing that FTL contract operation, you are basically implementing that particular contract methods. So that would kind of do fall into that. But there's another thing that we touch, like it's your design kind of evolve as your the requirements and the business knowledge starts increasing. So when you're starting out of the gate, you might not know how things might pan out. You might just call what the business is calling at that point of time. But as your requirements increase, then you kind of refactor it um, again and again to make it more uh, modular as the time goes on. So, that's another concept. I think it's talked in the book. I don't know whether it's in this chapter or the earlier chapter. Is that you like for a building architecture, right? You have to do the big design upfront, and then everything follows from there. Like the once the construction begins, there's no change in the design, or if there's a design change, it's a pretty big cost impact because
Mm.
it all involves about people, resources, material, and etc. But from a software perspective, we don't have that limitations in terms of that we need a 100% design ready before we start the thing, and that was a challenge with waterfall model where people were used to do that one, where you create a big design out there, and by the time that design gets approved, your requirements would have changed, and things just get messy. So the other approach is like you are in constant design mode. As and more features are get added, you kind of have to think back how the things work for you, whether things are making sense, those kind of a thing. So that's how that design kind of evolve during the project cycle. And as the design evolves, obviously your code starts improving as well. So when you're starting with very small use case, you don't have to worry about a lot of other things. But as things come out based upon your different requirements and features that start generating, you kind of have to evolve your design as well. It never remains set in stone. So that's where I was talking about that you have this thing like now I know that I have a contract operation, but there's some other thing comes in. Yeah, then I create a contract operation and make it a little bit more um, object oriented type design so that it becomes much more easier for people to understand what's happening.
Okay, that makes it clear.
Yeah, thanks for asking that. It's a good question. Uh, yeah, and yeah, so the whole idea is that you want the system to grow and change with minimal impact. So as the system grows, yeah, so whenever as if your design is good, what would happen is like you would be able to isolate the change, and the final impact to the code will be very less. Like the blast radius, if I would call it right. So whenever there's a change in a particular, whenever feature change comes in or a change request comes in, when you have to do that change, if your code is modular, the impact will be very less, and you only need to test those modules literally, and other things you don't need to test it. So that's having following this principle, you can kind of do that. And then yeah, as I said, using abstract classes and interface help with writing this kind of a thing, open for extension classes, and yeah, that would help you. And the other example is this SQL.java that refactored. It's clearly a open for extension thing. You don't really have to modify the abstract class. It will just either will always be only one generate method. Uh, but yeah, if there is another, if you want to write an execute query, obviously it will not fall into this particular class. It will have be a different class saying execute SQL execution or something. And then in that there will be a abstract method called execute. if yeah, if it comes to that. Uh, all right, I think that's it for today. Yeah, what we covered was based on a little bit discussion on what smaller classes look like and what deep classes look like. A single responsibility principle, cohesion, and open or closed class. So that those are the primary topic that I kind of gleaned out of that particular chapter. Again, one of the smaller chapters out there, but like it has got a very deep impact. So yeah, any thoughts?
Uh, yeah, just one, unless someone else wants to go ahead. Yeah.
No,
No,
go
one
ahead.
just top level thought that again coming but more from product manager perspective, it seems and there's more of sharing my comment or understanding of it. It seems that when we build systems, it's the nature of systems that we have to set them up so that they can accommodate change and complexity
That's correct.
fundamentally. Yeah,
That's
there.
correct.
And the way to think about how we can set up systems for change and complexity is to look through the lens of I mean, keeping it small, incrementally changing it as things become clearer,
Correct.
and making modifications as we go ahead, and then having this lens of these two dimensions, cohesion and coupling in there.
Yeah,
That are we keeping like the in terms of are we keeping them high cohesion and low coupling? And I keep this seeing this being touched upon in various
that's correct.
aspects
Yeah.
there. So this is just to paraphrase my understanding of it. One thing I was curious was because when I started learning about software development in part, like for example, the whole thing about solid principles would get it would be the discussion whole would start on solid principles, but this whole part about cohesion and coupling underlying the good design of systems, it's not touched upon much, and I'm just curious why. There maybe it's assumed or maybe that what's the fundamental problem that solid principles or that is trying to tackle. Is there a reason, or is it understood, or is it assumed? I was just curious
Yeah, I
to
think
have your
it's
comment.
yeah, I think it's under. I mean, yeah, I mean, like I think it's assumed to be known to people like you want to have high cohesion and low couple, and
Okay.
yeah,
Okay.
and if you look at right, this we are talking from a very small code perspective, right? Now the
Mm-hmm.
same thing if you multiply, if you go at a larger scale, like talking between say application servers and database servers.
Yeah.
Same scenario thing happen that application servers will have application logic into it, and database will have database logic.
Yeah.
So that
Yeah.
the change can be isolated. So and then it can again be expanded to a much more complex system where you have many applications residing and then between each applications, the
Yeah.
responsibility, the same single responsibility principle comes into the picture that this
Yeah.
application is supposed to do this and the other one do this. So the same concept, it just goes at a larger level. So if we are able to follow those principles at this base level, that's a code level,
Mm-hmm.
then that kind of
Mm-hmm.
the entire system, yeah, everybody will have that thought process across the whole architecture kind of a scenario, and then that
Mm-hmm.
helps you become more scalable and more robust across the whole
Okay.
system. Yeah.
Mm-hmm. Okay. Okay. I mean, and then no the challenge, for systems which are like I keep wanting that systems which are a lot of legacy code and all of that. How do they keep maintaining and how do they keep it? It's the nature of things to just get worse, especially a lot
Yeah.
of things. It's amazing how systems still are functioning well in spite
Yep.
of all that. Um,
So
there
yeah, the challenge that happens is like people, it works because I mean after a period of time, all the developers, the original developers go out, and then there are some new
yes,
set of
yes,
developers,
yeah,
and
yeah,
then if this that the principle had not been followed, and if somebody kind of, this is where like you need to have very strong development teams, like very senior teams. I think one of the examples, or one of the approach that most organization, like when most startups take, is like they take uh, people who don't have too much of experience, and then they just do it because they get at a cheaper rate, right? And then
Mm-hmm.
they get them to do the entire code. It goes very fast, but like 1 year down the line, when the number of complex pieces starts becoming bigger,
Yeah. Yeah.
then anybody who comes in, it for them it's very hard to make any change. And then it's like you're basically operating by the seat of your pants kind of a thing. Like you don't know whether the change is going to cause some production
Yeah.
incident, or if there are like a
Yeah.
lot of incidents coming and so on. So then that becomes a liability.
Yeah.
Uh,
Yeah.
so on the other hand, if you have a very high senior engineers out there,
Yeah.
I mean at least like 50% senior engineers who can like guide the juniors, then it kind of helps because then they ensure the guardrails are kept, the design remain as robust as possible. And if
Yeah.
somebody is deviating from it, they kind of say, you know what, you're doing it wrong. We could do it a better way, kind of a thing. So
Yeah.
in that scenario, that system remains clean, and as long as that system remains clean and the responsibilities are clear, it kind of
Yeah.
it keeps scaling up to a large extent.
Yeah. Yeah, yeah. So just building on that, I was curious that because I mean the breadth of code will become a lot. I mean, a lot of features, product features will keep coming up.
Yeah,
In terms of senior leaders, are there, let's say, three, four top level things that because you cannot keep taking care of everything? Is there some 80-20 approach or something? Is there some three, four things that high value or high levered approaches are there, which helps them to keep managing this these changes
yeah.
and complexities? There's something in practice. I mean, there's a theoretical part into what we have done, but it's just into the practice. How do they actually go about? There must be some three, four high leverage approaches or moves that they keep.
The one of the things that they have, I mean, like the organization that I work in right now, we have very strong um, code review system where
Mm-hmm.
yeah, I mean uh, so there are different layers of systems. So we have like architecture review, and then we have design review, and then we have code
Mm-hmm.
review, right? So there's
Yeah.
a review happening at each layer, and then there are
Mm-hmm.
sessions being shared. So that's one layer.
Mm-hmm.
Um, and there are there is there are some designated so and the other aspect is like the responsibilities for everyone to keep the code clean, but then there are few
Mm-hmm.
senior engineers who their job is not their job, it's just that they are passionate about it in terms of keeping the entire system clean, and they want to know each and every part of it. So
Mm-hmm.
that having those senior engineers, they kind of keep a tab if something goes out of the way. And obviously,
Mm-hmm.
we have systems like we have code checks, code quality checks, test
Mm-hmm.
coverage checks, security checks, everything, all automated, etc. And
Mm-hmm.
similarly, we try to reduce developer or the cognitive load, so that the developer doesn't have to think about things, like they can get everything. So the basic idea is that at any point of time, if you want to deploy a particular feature, your test
Mm-hmm.
environment, your production environment, and your local laptop environment should be as similar as possible. So
Mm-hmm.
whatever you are doing it on your development on your laptop, it should be replicable in your or whatever is in production should be replicable on your laptop to a certain extent. So by
Mm-hmm.
keeping that piece, you are able to test most of the things I can test like most of the things on my laptop, and
Mm-hmm.
having that uh, uh, features, like I can also debug it, like my environment code I can debug it. So there are a lot of engineering effort
Mm-hmm.
that goes in to
Yeah.
keep things moving, so that if the moment developers have to do too many things, that's
Yeah.
when they start slacking uh, on the code quality, because they are already
Yeah.
busy with so many other things that they need to maintain. Then they will not.
Mm-hmm.
For example, if I it becomes very hard for me to debug a particular code, or if it
Yeah.
takes like 30 minutes for me to deploy a code into a test environment, then that's a
Mm-hmm.
problem, because then I will not test as much as I want to.
Yeah.
Or if I have to compete against other developers for the same resources, then I will not test it. I will just leave it. I will ask, like, I will just leave it for somebody else to do that. But if it's
Mm-hmm.
like less time for me, or if the, for example, if I want to run, if I start up my application in 2 minutes or 3 minutes within my laptop, then
Mm-hmm.
yeah, then I would be more keen to do more. I would spend more time focusing on quality rather than setting the whole system up on my laptop every time. So
Mm-hmm.
there's a lot of engineering effort just to ensure that developers don't get bogged down by the other details of the setting up the infrastructure and deploying and running the code on the laptop and so on. Then there are
Yeah.
engineering effort on code quality, automation checks that can come in. Then there are process
Mm-hmm.
related things that we do. We have, yeah, obviously you have your code cannot be merged until some 2 or 3 people approve it.
Yeah.
And then like within teams we have code reviews where we we, we go through the code we write, and
Yeah.
sometimes what we do is we also do a kickoff. So even before we write the code, we kind of go through what we understand and what are the changes we are going to do and what are the impacts that
Yeah.
would happen. So there are multiple checkpoints that we need to implement to get to ensure that we do not uh, fall. I mean, we do not lose track of the quality. The
Yeah.
other aspect also is like even if somebody has done it in certain way, uh, there is a way mechanism where we have like a you don't call it, we have sessions where we can go and tackle tech debt, dedicated amount
Mm-hmm.
of time
Yeah, that
that we
also
can
requires separate, yeah,
yeah,
bandwidth. Yeah.
that yeah, a little bit of time that gets set up so that people get time to look at the tech debt and fix those things, or even improve things and so on. So it happens at a different, very, yeah, from an organized perspective, from a practical perspective, there are very different checks and balances, as well as like you share certain practices that you found to be useful for you, so that other people can
Mm-hmm.
use it. So yeah, that those things kind of keep things in, yeah, it's a good, in a good shape. Yeah, and then
Mm-hmm.
obviously there will be some places where somebody had done it and maybe somebody missed the change, and then it comes back in some tech debt session saying, okay, we need to fix this
True,
out.
true.
Yeah. So, and then I
Yeah,
think one
like,
of the other important culture that really
mm-hmm.
is about, yes, not uh, thinking about what was who did a particular change, um,
Mm-hmm.
but how we can remediate it, or what are the steps that we can do to remediate it. So that's
Mm-hmm.
another key. If yeah, if the focus is on who did it,
Yeah.
then it becomes a not a good environment to work in. Yeah, if yeah, the
Mm-hmm.
focus is on like how can we remedy it in a much better way, given where we are, then it becomes a
Mm-hmm.
better experience. Like in terms, like people, yeah, will respond to that culture a bit more, and they feel that ownership in terms of keeping that quality high. So that's another very important
Got
thing.
it. Got it.
Yeah,
Got it. Thanks. Thanks.
yeah,
It's helpful.
yeah.
Uh,
Uh,
yeah.
thanks.
Then see you next week.
Yeah, see you next week.
Then.
Yeah, thank you.
Okay. Okay. Sure.
See ya. Bye.
Thank you. Dishit, could you please
Yeah.
hang back for a bit?
Okay. Yeah. Sure.
Yeah, I just need a bit of
Uh,
career advice, career path
yeah. Just a
advice.
second. I'll just stop the recording.
Yeah, that would be better.
Yeah.